User Coordinate System. In nanoCAD, there are two coordinate systems, namely, the World WCS, World Coordinate System, and User Coordinate System UCS. At any given time, only one coordinate system is active, which is called the current one. The World Coordinate System is the base system and cannot be redefined. The main difference from the user system is that it remains in the same place and is stationary. And for each model space or sheet, it is the same. The User Coordinate System has almost no limitations. It can be located at any point in space and at any angle. Commands for working with coordinate systems are found in the View tab, Coordinates group. And now, to practice on these exercises, we will set a new UCS at the origin of this template. For this, we'll use the Set UCS by Point command. This command allows you to create a UCS at a new coordinate system starting point. Next, we will use the line and start entering coordinates either in the command line separated by commas, or through the dynamic input window. At first we set the initial coordinates of the first point. 10, 20, enter. No need to interrupt the command. Let's set the coordinate of the second point and pay attention to the command line. Next, x20. Y40, enter. And we can see that our line didn't hit the right point. By default, nanoCAD sets coordinates as relative coordinates when entering via dynamic input. That can be seen by that symbol in the command line. To change the coordinate input to absolute, click on the nanoCAD button and go to Options. Next, Dynamic Input. Pointer Input Options. Relative or absolute input format. And change the setting to use absolute format. Let's set the same coordinates. Next, x30, y20. Pay attention to the command line. That symbol is changed to the hashtag symbol. We can also add a hashtag character before we start typing to achieve a similar result. And, as you've understood, they are measured from the origin if the exact value is known for the x and y axes. This is how absolute coordinates work. The next coordinates are relative and are convenient to use when known, the offset from the specified point, which we will indicate manually graphically relative to the previous one. For this, let's use the line again. Also remember to reset the UCS to a new point. Now we will graphically set the first coordinate, and before entering relative coordinates, always enter that symbol. This point will be 0 for the subsequent. And in this way, we start a new count for x will be 10, for y, accordingly, 20. At symbol 10, 20, enter. The next coordinates we build in the same way, but before specifying the y-coordinate, you will need to enter a negative sign. At symbol x10, y-30, enter. Try the next construction on your own, and let's move on. Now let's briefly look at the operation of the polar coordinate system. Let's look at the example. Use the line and set the polar coordinate after standing at point 00. Polar coordinates imply construction by specifying a distance and indicating the angle value. 0, 0, enter. Now, let's use the dynamic input. We see that the approximate distance to the point is 14.1 and the angle is 45. Let's input it manually. 14 and 1 through a point. Next, press Tab and set the angle value to 45 degrees, then press Enter. This is how you can construct using polar coordinates, knowing the distance and angle value. Now, let's move on to studying the user coordinate system. First of all, note that all the modes used for changing the UCS are located in the View tab, under the Coordinates group. To set the world coordinate system, use this command, which is called clear UCS. It sets the parameters of the world coordinate system for the current user coordinate system. And before creating a new user coordinate system, keep in mind, after defining a new point of the coordinate system, it must be renamed. In this dialog box, all named UCS will appear. Also, the Settings group allows us to change the view when switching the UCS after establishing a new user system. Using the origin and angle, create a new user coordinate system. Arbitrarily on the drawing, we'll set a new point and angle. We see that the base directions, determined by Settings, Step, Grid, and Ortho, rotate together with the UCS. Now, let's go back to the Coordinate System Manager. Right-click on the new coordinate system. Let's name it New UCS. From the drop-down list, we can switch between systems, and also, if we need the initial position of the world coordinate system again, we can return using this button. Let's return to the world coordinate system and look at what other methods we can use to create a new coordinate system. The first is coordinate system. This command allows creating a new UCS using 3 points X, Y, Z. We can also create a UCS by rotating around an axis, using only origin, an origin and angle, in the direction of the Z-axis, and by 3 points. Also, what should be noted here is how we can attach to an object. In this table for object attachment, we can look at how the origin of the new UCS aligns with points located on the given elements. Let's use the Set UCS by Object. We can see that the origin of the new UCS aligns with the end of the line that is located closer to the selection point. Accordingly, for an arc, the coordinate system's origin will align with the center of the arc, for a circle in the same way with the circle's center. The point becomes the origin of the new UCS. For the polyline, the new UCS origin aligns with the starting point of the polyline. Next, for dimensions, the new UCS origin aligns with the middle of the dimension text. And for the text of block entry and attribute definition, the new UCS origin aligns with the insertion point, and the direction of the new x-axis is determined by the rotation angle.